right. In a way, we're going to kind of go back and just review the idea of what an integral is, okay? And try and understand it a little bit more in depth, okay? What does an integral do? Okay, it finds the area under the curve between bounds, right? From this point to this point. But you have to be careful with that. Okay, well, what am I talking about? If I say here's a function and I want you to find, let's say the integral from 0 to a of f of x dx. Is it truly the area under the curve that we're finding when we find the integral? No. Because what do we know about this area? It's positive. And what is this area? No, it's positive, because area is always positive, right? So if I'm looking for the actual area, let's say the area of this piece is 7 and the area of this piece is 3. What is the actual area of that whole thing? 10. But the integral is not 10. The integral would be what? 4, because we would say 7 minus 3. Okay? So there is a difference between finding the actual area and finding the integral. You guys okay with that? Does that make sense? The integral puts into place the idea of the area not being negative, but telling us that it's below, that region is below the axis. Does that make sense? Okay. So, what did I have up here? Finding the area under the curve, but not really, right? This is the net area. What we're actually finding in the integral is not the real area, we're finding the net area. What does net mean? The net is, the actual definition of net, is the remaining amount after all deductions and losses and everything else, okay? Deductions of charges, outlays, or loss. Okay? And again, what's the other word? There's net and there's gross. True. Okay? Gross, in terms of pay, is how much you've actually earned. Net is how much you actually get. Right? Yeah. So, when we're taking the integral, we're taking the net area. So we're saying, okay, we've got 7 that we've earned, and then they took 3 away. Right? Okay. So let's look at this example here. You had something like this on your quiz, so maybe this helps you a little bit. I don't know. If I want to find the integral from a to b of f of x dx, what is it you have to do? Well, there's no function here, right? This is a piecewise function, really. So if it's a piecewise function, you kind of got to play around with it a little bit. So how could I rewrite that integral so that it's something that I can actually evaluate maybe?
From like a to 0. Cut them into small.
Where would you cut it? Where would you say I got a point where I've got to stop evaluating and then start up another evaluation? To negative 1?
Well, like they said, it's negative 1, right? If you draw a line down from that, it's a triangle.
Okay, fair enough.
And then you make a trapezoid.
Okay.
You could do a trapezoid.
And then you could go from negative 1 to 1, then you could go from 1 to 3.
There's a trapezoid also, right?
Right, but the key, the big point where everything changes is right here, right at 3, right? Mm-hmm. So basically, how would you rewrite this integral? What rule would we apply here? The plus rule, the sum, right? So how could I rewrite this integral? The integral from? We'll call C.
There you go. From A to C.
So the integral from a to c of f of x dx plus the integral from c to b of f of x dx.
Yep.
Right? Now it's going to give you the same answer either way, because what does integral actually mean? We're not finding the area, we're finding the net area. And so we have to differentiate between those two things. So what is the integral from a to c? How would you go about doing that? Okay. Well, let's do this. So the integral from a to c of f of x dx is what? The trapezoid, right?
Yes.
Area of a trapezoid is 1/2. What's b1? 5, so the bottom base is 5, plus what's the top base? 2, and what is the height? 2. Now, in other concepts, in other things, we've been taking the trapezoid and putting it on its end and counting the bases as the heights,
Oh, yeah.
right? But in this case, it's just laying flat. So that's the integral of from A to C. It's the trapezoid. Now we have to add to that the integral from C to B of f of x dx. But what's key about the integral from C to B? It's going to be a negative value. Now from C to B, which direction are we heading? From C to B. We're moving to the right. So is that distance in the positive or negative direction? Positive. So what is it that makes this negative? It's below the axis. So we would say plus, what do we have? A triangle? So 1/2, what's the base? 2. Now what's the height? It is 2, but it's in the negative direction. You guys okay with that? So we would say what? This is 7, right? That's it? And then minus 2, which is 5.
Mr. Bundy,
I got you a second. Go ahead.
If it goes backwards and then the direction is negative, is the answer still negative? Or
Okay, well, all right. So we have the integral from C to B of f of x dx, right?
Yeah.
We said it's 1/2 of a positive 2 because we're going from C to B to the right, and we're going down 2. So we get a negative number here, right?
Yeah.
If I go the other way, then what's my lower limit?
It's B.
I'm starting at B and going to C. So let's analyze that a little bit. That would be 1/2 of, now what's the base length? It's still 2, but we're going from B to C, so we're heading negative. And then the other one is still negative because it's still below, so it would be positive 2.
So it does look
And think about it. What did we do with the limits? We flipped them, and what's the rule? If you flip the limits, you change the sign. So it's good because we're looking at it different ways. Good question. That was it? Wow, you guys are good. Okay. So now I did it a little different when I did this. I broke it into pieces. I said a triangle, so that's 1. That rectangle or square is 4, and then that triangle is 2. And then the other one is what? Negative 2, right? Because it's a triangle. So we end up with 5. So that is called the net area, but we just say integral, okay? Just the integral is that. It's the net area. So what do we call it if we want the actual area? Yeah, gross would be nice, right? The total area. We're going to use the word total area, okay? Total area implies I want the area of the actual object. I want the real geometric value.
that's not the real geometric value?
No, because area in geometry is always positive, right? No. So what would the total area be? Well, what was the area from A to C? The area from A to C was 7. What was the actual area from C to B? 2, because area is positive. So what is the total area? 9. So we say the total area is 7 plus 2 instead of 7 minus 2. You guys okay with that? You just have to know the difference between, am I asking for the integral or am I asking for the total area? Am I asking for net area or total area? Get in your brain that integral means net area. Okay? Which one then is more difficult to find, the net area or the total area? The total actually ends up being more difficult because if I give you an equation that looks like this, let's say the integral of x from -1 to 1 dx, that one's easy analytically, isn't it? What do? So you do 1/2 x squared from -1 to 1, which is 1/2 of 1 squared minus 1/2 of -1 squared, right? Which is what? 1/2 minus 1/2 is 0. But what did I find? I found the integral, the net area. How would you go about analytically showing the total area? At what though?
Well, I think before we had the upper bound and lower bound, we used to subtract the total of the upper and lower
I think maybe in this particular case that works, but not always. Let's look at this graphically. Let's look at this graphically. X is what? X is a line with a y-intercept of 0 and a slope of 1. So we have this, and we're going from -1 to 1. So the reason it's 0 is because these triangles cancel each other out, right? But if I'm looking for total area, how would I have to break this up in order to find the actual area? So what do we do? The integral from -1 to 0 of x dx. But what's wrong with that? From -1 to 0, what's the integral going to be? From -1 to 0, what's the integral? It's going to be negative. But we want total area, so we want that to be what? There it is. Plus the integral from 0 to 1 of x dx. Now, do I have to take the absolute value of that? No. Does it hurt me if I do?
Yes.
Because if the answer here is positive and I take the absolute value, what do I get? Positive. If the answer is negative, I want it to be positive, so I take the absolute value. So the absolute value can't hurt this one. So this would be total area here. So you can see it's a lot more difficult analytically to comprehend. Does that
Do you
make
have
sense?
to break it up into intervals of 1? Like, what if it was a big...
True. Where would the intervals break? Where would we be concerned with things changing? When it crosses the x-axis, right? So we were concerned at C because that's when our integral started dealing with negative values. And we're concerned here at 0 because that's when it changed. Total area. So this is what we're talking about here. The total area is all the areas added up, and all those areas are positive values. Okay? So what did we just say? What do you have to do to find the total area? What's the main concept? What? Absolute value. But I have to ask this question. Okay, it is the absolute value, but which methodology would allow us to get the right answer? Would it be the absolute value of the integral, or would it be the integral of the absolute value? If I just take the integral, let's say the function is strictly negative, so it's below the x-axis, right? Strictly negative. If I just take that integral, I'm going to get a negative value. When I take the absolute value of that, then it becomes positive. So that's okay. But what happens if the function has some above and some below? Well, what does taking the integral here imply? This right here, ignore the absolute values. What's the integral from a to b of f of x dx? This is the net area. So when I take the absolute value, am I actually finding the total area?
No.
Let's go back to the previous problem real fast. If I were to take the absolute value, where is it? If I were to take the absolute value of this function, what would I get? I would get 5, because this is the integral from a to b. So if I take the absolute value, I get 5. But was that the total area? No. So I don't want to take the absolute value of the overall integral. Let's get there. Okay, I want to do this one. That's right. Good job. Okay. Why is that true, though? Try and understand that. So this is just changing the sign of the net area. That doesn't give us a different value. It just gives us a different sign. This guy, what are we saying here? Think about what it means to be an integral. Remember, this elongated s kind of means what? It means the sum, in a way, right? The sum of what? The sum of the areas of what kind of shapes? What were we doing? We were slicing it into how many rectangles? Infinitely many rectangles, right? What did the dx represent in those rectangles? The dx represented, yeah, but in terms of the rectangle. It was the width of the rectangle. What did the f of x represent? The height of the rectangle, right? So, what we're saying is we're taking the height of each rectangle, but we're making sure that each height is what value? A positive value, and then we're multiplying it by the width of each rectangle, and then we're adding them up by taking the integral. Does that make sense? So when we want total area, we take the integral of the absolute value, not the absolute value of the integral. Okay. So let's find the net area and the total area of this function. This one's going to be a calculator problem. Well, what I want you to do in your notes real fast is I want you to write down the equation. Give me the equation that gives me the net area, and give me another equation that gives me the total area. So just look back and say, how do I find net area? How do I find total area? Okay, so what is the equation? What is the equation for net area? Net area equals what? No, the equation. The integral from pi over 4 to 7 pi over 4 of x cosine of 2x dx. That's net area, right? Because net area means after you do what? After you add up and subtract all the things going on, right? And that's what integral means, okay? The total area is the absolute value of the integral?
Yeah.
No.
No, the absolute value.
What would the equation be for total area?
Okay, so
The integral from pi over 4 to 7 pi over 4,
and then absolute value of
the
x
absolute value of x cosine of 2x dx.
Oh, you forgot the other part of the absolute value.
Hey, I got it.
You guys okay with that? That's the key to it. Okay? Now, in this case, we can't even do this analytically because we don't know the antiderivative of x cosine of x, right? So, lucky for us, we have a calculator to do this problem. So go ahead and figure out both of these, if you dare. All right, what did you guys get for net area? Oh, that sounds like something, right? Pi. Pi. All right, what is the total area?
Yeah, I got negative.
Total area can't be negative. What is it? 9.425? Okay. Which probably means this is what? What does that look like? Maybe 3 pi. Okay. So, let's do this. In your y list, you have your y list as x cosine of 2x for y1. Okay, type this function, or this integrand, into your y list as y2. Okay, how do you type this as your y2? The integrand of this function is y2. So how are you going to type that in your calculator? No, you need absolute value. So, what do? You got to go to catalog, and then ABS is absolute value. Seriously, do this, okay? If you need help, I'll come around. But get them both in your Y list. Make sure your window is from pi over 4 to 7 pi over 4. Make sure you got a big enough Y window to see the whole graph, and graph both of them. Not an exact reflection, right? If you're looking at this function, x cosine of 2x, you notice, I don't know what it looks like, but you notice something like this where it bounces back and forth between the x-axis, right? For the total area, what do you notice? It does like this. Am I right? So you can see that this is actually going to give you your total area because this region here, this region is the same as this. This region is the same as this. It just does what? Made it positive. And that's what we want. We want all the areas to be positive. And then this region is the same as this region. And then this region is the same as this. It's just, that's the absolute value of it. So we put the absolute value inside so that it breaks it into its everything's positive. It breaks into pieces where everything's above the x-axis. Does that make sense? Okay. So that's the graphical or calculator approach. So net area is the integral of x cosine of 2x dx, and the total area is the same thing, but it's the absolute value of the integrand. When asking for the area, this is key, guys. Okay? Just like back in first semester, if I said, what is the rate, what am I asking for? But what am I really, what's the words? Yeah, derivative, that's how you go about it. But what am I asking for when I just say, what's the rate of this? I'm asking for the instantaneous rate. If I want the average rate, I have to say average rate. If I just say rate, I mean instantaneous. If I just say area, do I mean the total or the net? I mean the total area, because area is a geometric concept. Okay? So if I ask for rate, I want the instantaneous rate. If I ask for area, I want the total area. I want the geometric concept of area. Okay? Can I go on? Try this one. What is the area? Oh, this is good. I like this problem. All right. So I've got two functions now. I want to find the area that is bounded by those two functions. So for right now, I want you to just type those two functions in your calculator and see what they look like. Make sure you have a decent window. So what is maybe the left-hand limit of your window? Your x minimum. Yeah, it doesn't really say, -10. Okay. What's your x maximum? Maybe. Okay, we don't know for sure. But what would your y minimum be? What is the lowest either one of these functions is going to go? What is the lowest this one's going to go? This part will go down to -1, but I've got a -1 out front. So -2, that's the lowest this will go, and this is -2, right? What's the highest these functions will go? 0, because the highest this will go is 1, and then plus -1 is 0. So you could just make it from -3, y minimum -3 to y max 1, just so you can see. When you graph it, you get an oscillating function, it's cosine, right? Now notice what this is saying. It says, I only want the area that's bounded by a certain set of values. I'm not looking for this really long, ridiculous area. I'm looking for, if you think about cosine, it's cosine with a shift of what? Down 1. So it's going to look something like this, right? And then same thing over here. Okay, whatever. And then down here, you have y equals -2, and it hits right there, right? Oh, that didn't work. Okay, well, anyway, we'll pretend that's it. All right. You guys got that? Now read what it says. It says it's bounded by the curve, it's bounded by the line, and it's also bounded by the y-axis. So here's the y-axis. We're bounded here. We're bounded by the curve. And we're bounded by the line. So we're finding the area of this region here. You guys see that? Okay. Now if I also include this over here, am I using the y-axis to bound anything? No. So that doesn't make sense. So I could find this region or this region, but they're going to be the same thing because this is oscillating, it's repeating, right? It's a reflection of itself. True, that's what I'm saying. So if you found just this piece, that's going to be the same thing because you can see it's a reflection.
Oh, so you're just gonna like multiply by 2?
No, because then you'd be finding the area of this whole thing, and that would make us not bounded by the y-axis anymore. That means the y-axis, cut it off. Don't look at it beyond that. How do you know what?
Like from the x-axis, how do you know like what marks
From the x-axis?
like
Well,
finding the area?
Like how the bound?
Yeah, because can't we just find the rest?
Fair enough, but we're looking for the regions that's strictly bounded. So this, it's like, okay, I'm free, and then I hit something. Now I have to stop.
Okay, so bounded by the y-axis, we only use that.
Right, this little, yeah. Now, if this didn't intersect, like if this was like this, and there was like a gap here, then there's no way to solve it because it's like an infinite thing. Yes. In this particular case, it doesn't matter because it's a reflection. If it did matter, and like this side was bigger than this side, then I would say like in quadrant 2, quadrant 4, or something like that. I'll give you more information to be able to solve it. Okay, so let's see if we can understand an approach to this. That's what we're looking for. We're looking for the area of the region that's outlined by blue,
Why are we just looking at that region?
because that's what it said.
And it's so sorry.
It's bounded by the curve, it's bounded by y equals -2, and it's bounded by the y-axis, so only that. Is this region bounded by y equals 2? No, it's bounded by the x-axis and the curve, so that's not important. Why did I put pi as a critical x value?
Because that's the valley.
Because that is where this curve and this line intersect. How do you know that? Because, I mean, theoretically, if I plug in pi, what's cosine of pi? -1, so -1 plus -1 is -2, and that's the curve there, right? Okay? If you need to, you would set them equal. You'd say -2 equals -1 plus cosine of x. Solve it, so this is -1 equals cosine of x. So when does cosine of x equal -1? When x equals pi. So that's where they intersect, I guess. Okay? So any ideas on how to approach that problem? Okay, let's look at it. If I take the integral from 0 to pi of -1 plus cosine of x dx, what am I finding?
That area.
I'm finding the net area of what, though? There it is. Okay. That area, the green area. If I take the integral, the green area, if I'm looking for the area of the green, that would be the integral from 0 to pi of -1 plus cosine of x. Obviously the absolute value because we want area. We want the net area. Does that make sense? The integral is the net area that's bounded by the curve and the x-axis. So that region, the green region, is the integral of -1 plus cosine of x, or the integral of the absolute value. How would I then find the integral, or sorry, how would I find the area of the blue region? Subtract what?
Oh, you find the area of the rectangle, you subtract the area that you find.
Okay, so the whole shape makes a what? A rectangle, so you can find the area of that and then do what? Subtract. But what's another equation, instead of saying, oh, it's a rectangle, what's another equation that will give me that area? If the integral, if that integral gives me the green area, the integral of -2. But again, we want the absolute value of it. So we would say, let's see, we don't want the green area, we want the blue area, right? That area. Sorry, I'm a little bit ahead of myself. So what I'm going to do is find the area of the whole rectangle. Okay? In other words, the yellow rectangle. So the yellow area is the integral from 0 to pi of
-1 plus cosine.
what's the function that bounds that rectangle? -2. But do I want the integral of -2? No, because what kind of answer am I going to get? Absolute value. I'm going to get a negative, so I got to take the absolute value. So the yellow area is the integral from 0 to pi of absolute value -2. The green area is up there. What am I going to do with the yellow area and the green area to find the blue area? Subtract them. So I would say that the answer that I want is the yellow area minus the green area, or the integral of the yellow region minus the integral of the green region. So that's gross. It's just pi, by the way. Because you can type that in your calculator and figure it out, right? Analytically, like we said before, analytically this stuff gets a little bit more difficult because you can't just take the integral of the function, take the antiderivative, and that's it. You have to figure out where the function crosses the x-axis. You have to figure out where the net area changes, the region changes from positive to negative, and then you have to evaluate each one. Okay, so let's take a look at this one. Y equals 4 minus x squared. I want the area, meaning what? The total area of the region bounded by y and the x-axis from 0 to 3. So graph this on your own without a calculator. And I want you to bound it by 0 and 3. So that means draw vertical lines at 0 and 3. I'll give you a minute to do this. All right. If you need an XY list, what's the first X you're going to plug in? 0. When I plug in 0, what do I get? 4. Okay. Beyond that, you should know this is a parabola that opens down because the x squared is negative. Okay. Is there any horizontal shift to this? No. Okay. And if I need to find the y-intercepts, how do I find the y-intercepts? Plug in 0 to y, right? If I plug in 0 to y, what do? Plug in 0 to y. What's x? No. Okay, so these are my x-intercepts. So you can see the parabola. It's doing something like this, right?
Wait, why are you going that far though?
True, but I'm showing because you didn't even know it was a parabola to start with.
Oh, I see it now.
All right. So now we are going from 0 to 3. So we don't care about everything over there. We only care about from 0 to... Oh, what does that mean? Where's 3 at? It's past. Okay? So what are we looking for? We're looking for this and this. Okay? Yeah. Why is it what? That side. Because it says we're bounding it from 0 to 3. From x equals 0 to x equals 3. Like, why not down here? Because when we're taking, well, it says, find the area of the region bounded by the x-axis. So, this area is not bounded by the x-axis. Okay. So the problem is, by just taking the integral, what are we finding? No, if I'm taking the integral, I'm finding the net area, okay? But what happens with this piece? This is a negative. I don't want that. I want total area, so I need to make this what? Positive. So we're going to graph it, which I did already, okay? Okay. And I guess a little bit more elaborate so it's easier to see, okay? So this is giving me my critical points here. So what is the integral from 0 to 2 going to give me? That's going to give me this region, right? So what would the equation be for this guy? Yeah, there we go. The integral from 0 to 2 of 4 minus x squared dx is the first part. Now this part, do you know how to take the antiderivative of an absolute value? No. So you know that when I just take the integral from 2 to 3 of 4 minus x squared dx, what kind of answer am I going to get? Negative, but I don't want it to be negative. I want it to be positive, right? So I'm going to, well, yeah, you could, or you could say minus instead. You see, why is that? If I want the integral from 0 to 3 of 4 minus x squared dx, that is finding the net area. So that would be a positive value and a negative value, right? I could break this down into the integral from 0 to 2 of 4 minus x squared dx plus the integral from 2 to 3 of 4 minus x squared dx. But that still is the same thing as this, right? What do I want? I want this value to be positive, and I want this value to be positive. So since I want to make this positive, I'm just going to multiply it by negative 1 in a sense. Okay? You guess? All right, let me do this. Maybe this helps you. Is that better?
Yeah.
So that integral from 0 to 2 is just that green region. And then we end up with 16 over 3. And I'm not going to dwell on that because that's just practicing integrals. You guys can do that on your own. The integral from 2 to 3 is what? It will be negative. Okay? That's that region. That's negative 7/3. But if I want the area, What do I have to do with that negative 7/3? Make it positive. That's why I put the negative out front, because I knew this answer was going to be negative.
Oh, or you can do it like that and make it positive.
Or you can take the absolute value.
It's the same exact.
Say that again, Dakota. Add the absolute values to the integrals. So you get, if you want to look at it that way, you get, what, 23 over 3?